Hello friends, today we are going to talk about global variables and large register file versus cache memory. Okay, now I hope all of you know what is a global variable. Think about it. What is a global variable? It's a variable which can be used by all the procedures in your high level language program. Am I right? Think of any program in any language which you know, and now uh, try to write a program where you have at least one different method other than main, method or function other than main. Okay, try to write that. Then let's say I have a program to add two numbers and I have written a function for adding two numbers. Okay, and I'm going to pass the two numbers which are need to be added to the given function, to add function. Okay, I have given the name as add. Now when I call that function add function, then and then only that function will be executed. Now all the variables which are declared in that functions block, those will be your local variables, and the variables which can be used by all the procedure. The local variables can only be used by the same function in which that variable is declared. Okay, but in some cases we have global variables which can be used by all your methods or functions. Now, where are you going to store these variables? In the last lecture, we have talked about a different block, a different register window for different procedures, the different functions. I hope you remember. Now, how are you going to store these global variables? That is the question. Variables declared as global in an high-level language can be assigned memory locations by the compiler. And all the machine instructions that reference these variables will use memory reference operands. So what we are going to do is we are going to store these global variables in memory. And when I'm talking about memory, I mean your RAM memory. Okay, so it's going to take bit of a longer amount of time for the processor to fetch the operands or the variables from your memory into your processor. Okay, so what the alternative is, it's to incorporate a set of global registers in the processor. That means there will be registers, a set of registers which will be assigned for only global variables. And these registers would be fixed in number and available to all procedures. A unified numbering scheme can be used to simplify the instruction format. In the last lecture, I told you, we talked about this. For procedure A, there will be a set of registers. For procedure B, there will be a set of registers. For procedure C, there will be a set of registers. But what if we want to store a global variable? What we can do is we can get another set of registers assigned for global variables only. So let's say this is my register set for global variables. So this is not for a single procedure, it is for all the procedure. This can be used for all the procedures. And in the last lecture, I also told you that when that procedure is being executed, that uh, block of registers or that set of registers will only be active. But in this case, this will be active. If there is a global register, there is a set of registers for global variables, then this will be available for all the procedures. Okay, so that will be, in this case, it will be easier for processor to get the global variables from your processor registers itself. Okay, so that was all about global variables. Now let's talk about large register file versus cache memory. So first, let's try to understand these two concepts. As we have already talked about, a larger register file means considering more number of registers. A large register file means uh, considering more number of registers for storing all your variables which are used frequently. The operands which are used frequently can be stored in your registers, and this is how we can reduce the time. Okay, uh, but uh, the disadvantage for this is register file is a register file may make inefficient use of space because not all procedure will need the full window space allotted to them. Are you getting my point? See, here you can see we have allotted a window for every procedure. But what if that procedure doesn't need that window, the whole window? All that memory is wasted. Um, and when we are talking about a register file, saving in other areas is not possible. So everything regarding this procedure A will be stored in this allotted window only. Uh, Everything related to procedure B will be stored in this window only. You cannot store anywhere else. That is uh, one of another disadvantage. Then the register file contains only those variables in use. So see, the register file contains only those variables which are in use. But what if you want to um, fetch while processing? While processing something, the process needs another variable from your memory. Then again, uh, the processor has to go to the memory and fetch that variable, fetch that operand, and process the remaining, complete the remaining process. Okay. Now let's talk about cache. So we have just talked about the advantages and disadvantages of a register file. Now let's talk about a cache memory. What's a cache memory? Cache memory is a memory which is situated between your RAM and your processor. Okay, just give me a minute. Okay, let's see what we can do here. Okay, let's consider this as your cache memory. This is your processor's registers as it is. So let's just consider this as your processor. This is your cache memory, and this is your RAM. Uh, Remember, your RAM memory is much larger than your cache memory. and cache memory's speed is very much faster, very much higher than your RAM memory. We'll just draw another table. This is actually your RAM memory. Okay. This is your RAM, and this is your cache memory. Let's first talk about what is a cache memory and how it works. Cache memory is very much faster than your RAM memory. Okay, so it's like about uh, thousands of factors away uh, regarding the speed. I mean, if its speed is, let's say, the time required for a processor to get data from RAM is, let's say, 10 raised to minus 6 seconds. Okay, then the time required for the processor to get data from cache memory will be around 10 raised to minus 10 seconds, even much less than that. Because this is a cache memory, it is a very expensive memory and it is very much faster memory. That's why its capacity will be very much lower. So it will be almost like few bytes only. Only few words will be there. And now how it works is it fetches that block from your RAM into the cache memory. Then from that block, the data will be accessed by your processor. Is that clear? Now, see, there are, let's say, there are four words in your cache memory. So your RAM, RAM will be divided into set of four words. This will be first block. This will be your second block. This will be your third block. Okay, and so on. So when the one block is fetched, these four words will be fetched into your cache memory. Then your processor is going to check whether the required data is available in the cache memory or not. Then if it is available, it will get it from cache. Otherwise, it will replace the block in cache memory. Then you are going to replace, if the data is not available, you are going to replace this block with the second block. Second block will be fetched. Second block of four words will be fetched. It will be copied into your cache memory. Then again, processor will check whether the data required is available in your cache memory or not. Then it is going to uh, proceed further with its processes. Okay, I hope the concept of cache memory is clear to you now. Now let's talk about the advantages and disadvantages as compared to your larger register file. So, uh, These are the this is the advantage. The cache memory holds a selection of recently used scalar variables. It actually there are different ways what should be the cache memory's content. We'll study it in mapping, memory mapping. Okay, so don't worry about that right now. Just remember, the cache memory holds a selection of recently used scalar variables. Then the cache may make more efficient use of space because it is reacting to the situation dynamically. This is very important. See, your cache memory will be reacting to the situation dynamically. Means if the data is not available in the cache memory, then it is going to uh, the processor is going to replace the block in cache memory with another block in your RAM. Okay, so it is reacting to the situation dynamically. Uh, Another advantage is saving in other areas is possible with a cache memory. You can store in any location. You can store anything in any location. There is no restriction about in your cache memory. Where should you store any kind of data? Um, and cache memory is capable of handling global as well as local variables. But this is the disadvantage. Data are read into the cache in blocks. So what happens is this is one of the disadvantage because sometimes all the data might not be needed, but you are fetching that whole block anyways. Okay, so that is one of the main disadvantage. You can see, and another disadvantage of cache memory is uh, when you want to access data from cache, you have to specify the address of your required data, even in cache memory. And you have to specify the full length address of your whatever data is required if you are using cache memory. In the case of register file, you don't have to specify the whole address. Okay, so the instruction format will be simple in case of register file if you are using register file, and the decoding will also be easier in this case. But in this case, if you are going to use cache memory, then the instruction format will be a little bit complicated. See the space required for storing the address. Space required for storing the address. Less space, more space. Now, so we'll talk about these tags and the address of cache in our next session when we'll talk about the mappings, memory mapping. Okay, so so using register file is better option than using cache memory. Okay, so let's stop here for today and we'll continue our next point in our next lecture.